Who of you likes spam? One. I think all of us had made the experience that our inboxes are filled with messages we don't want, or our messenger gets information from somewhere we don't have had contact in the past, and this information is nothing we want to have. In the current world, there are some protection mechanisms. Now, today, I want to talk about this aspect of Web3 messaging, how this can help us to make a very good spam protection in the future. Yeah, I want to talk a little bit about the messaging world and everything which is around this. Then I want to give you a short introduction into the DM3 protocol, what we are doing, and the approach we propose to solve these problems. And then we will talk about the spam protection and what mechanisms we have in Web3 and how we can use them effectively. So when we go back in history, the first real messaging solution in the internet was email. So in the very beginning, in the 70s of the last century, there started messaging by having the ability to send an email from one to another. And this was actually one of the first real killer applications of the internet. So a lot of traction came to this because now it was possible to send fully electronically a message from one position to another. So at this time, messages were not encrypted at all. Actually, at this time, this was a kind of weapon. It was hosted by the military, so in private usage, encryption was not really available. But it was a kind of decentralized because we had these different post office servers, and this worked well. And we know all of us are using email, and when we look back to our beginnings, it was something really interesting. Now we are using it still, and it's exactly the same. Not encrypted for the most times, but used almost everywhere. In the last 15, 20 years, we also did see these messages coming to life. So first we had this internet messenger like ICQ and others, and then WhatsApp and others came and filled a whole space in our communication. And right now, it's so that most of the people are using Web2 messengers for their communication with friends, family, and also for business reasons. So it is nice, it works well, it's really convenient to use, but when we see these ecosystems, they are completely closed and separated ecosystems. If I'm using one messenger, I cannot communicate with someone who is using another messenger. Now, these are closed ecosystems. And they are controlled by these big companies. They are controlling the user data. They are controlling my identity in this messaging ecosystem. And they are, even if they have encryption installed right now, so most of the big messengers are providing encryption, a lot of messaging solutions are not providing encryption until now. So if you are in a website where in-app messaging is, for instance, if you are using a video portal, then you have messaging components, and in the most cases you don't know, is this communication encrypted, is it not? If I'm leaving this tool, can I access this information again later? We have these silo systems. And if they are going down, in Germany, several times in the last years, even the big messenger servers went down and no communication was possible. So what are the problems? I mentioned most of them. We have the encryption problem. So for email, it's the most recent problem. So I don't know who of you received sometimes an encrypted email. So I tried it for several years. I sent my public key always with my mail. I never received a single encrypted email back, always unencrypted messaging. Then we have privacy. So when I'm using such a centralized messaging service, even if the message is encrypted by itself, the metadata is not. So the provider is fully aware of what or whom I'm contacting, and so these metadata are not private at all at the moment. I'm not self-surrendering for messages. If I want to move from one messenger to another, it's not possible, or almost not possible, because I'm not controlling my messages, they are controlled by this company. So interoperability I also mentioned before. So if I'm using messenger 1 and my friend is using another messenger, I cannot send a message. It's not possible for now because they are closed ecosystems, and most of these big messengers also have not the real intent to change this, because if they are the monopolists, they are fine with this. Centralization and single point of failure, I also mentioned already. We have these services, and if the service goes down or blocks me, I'm out of the system. Yeah, and last but not least, spam. So especially in the email world, so my email was revealed in some hacks in the past, so it's almost unusable. Even if I'm using spam filters and all the things my provider is giving me, I get a lot of spam mails. And also, in the other direction, it works not very well. Sometimes I receive an important message, and it is marked as spam because some rules of the filter are filtering this message out. So what can Web3 do to make this situation better? So first, we have key-based, we can have a key-based identity. That means everything is connected with my wallet. And having my signatures makes very clear what the message, or where the message comes from, and it's connected to me. So nobody can take over my identity. And I should be able to self-sovereign control where my messages are located and what I'm doing with these messages. We should do decentralization, of course, and so that we don't have any single point of failures. Encryption privacy, of course, is mandatory, so we don't need to talk about this. This is something it must be. And something we practice in Web3 is also very important, diversity. So we learned it from the clients for the blockchain. It's really important to have diversity, because if someone breaks or something breaks, something else can run. And when we look in the messaging world, if we have different messengers focused on different problems or different communities, it's really a good thing. But what we need is interoperability. We need to be connected even if we are in a different ecosystem or in a different community. And I already mentioned spam protection is very important. And with Web3 mechanisms, we can do a very good spam protection. So, but what is really essential? It is essential that we can share the encryption and transmission information. We are using a central but decentralized registry using blockchain based on ENS. We have a registry where all this information can be published so that others can get it and contact me on the platform. The second thing what we really need is a decentralized system. We are using a decentralized system of independent nodes which act as relays for the messages, so that if I want to send a message, I look into the registry, get the information where to deliver, and then this delivery service node relays this message until the receiver picks it up. And nothing more is needed into this network. And of course, interoperability is important. If Web3 messaging wants to be successful in the future, we need interoperability. We cannot do the same mistakes which are done in the Web2. So we need to be interoperable between all these different messengers, all these different ecosystems. With this intent, we started several months ago developing the DM3 protocol, and we designed DM3 as a layer 0, layer 1 protocol for messaging. Why layer 0, layer 1? Layer 1, of course, you can use the DM3 protocol to build your application on top of it. Now, if you want to build a messaging application, you can use this protocol, everything is fine. But we are also providing functions for a layer 0 protocol, which means we can use DM3 to connect other messaging protocols or services together so that we can build this connected ecosystem. As I said before, we are using ENS as the central but decentralized registry for this information and this network of decentralized delivery service nodes. How does it work? When one user is sending a message to someone else, he looks into the registry, gets the information how to encrypt the message, gets the information how to deliver the message, and then picks one of these independent delivery services and delivers the message. These delivery services are holding or caching these messages until the receiver is picking them up, and then the message is deleted from the delivery service, because then the application of the receiver is responsible to store and to work with this message. And also these delivery services can act as gateways to other ecosystems or other services. For instance, if there is another network which is also providing messaging, they can use a delivery service to receive the DM3 message and inject it into this other network. And with this, we have a very easy way to connect to other services. Even if these are centralized or decentralized services, we don't care. This delivery service network makes it possible to have these gateways to all of these systems. So I don't want to talk a lot about this picture. I only want to show it to you. This is the tech stack of the DM3 protocol. We have this base layer on the blockchain with ENS as the registry and also other name service, and the ability to link sources from other sources like layer 2 or centralized service into your ENS domain, so that you can share your profile if it is on layer 1 or on any other location where you have stored it. Then we have this protocol layer, and I talked a little bit about the transport or the message transport protocol. Now, this is this bar in the this bar here. We have this message transport protocol, which is this lean-based protocol for transferring messages. We have a lot of other protocol extensions, not all of them are already implemented, so that we can provide functions which are needed in any messaging application. And then we have this application layer where we have these interfaces to other protocols or other solutions, and we have these embedded solutions so that you have components you can use inside your dApp, and with one single line of code, you can add a full secure messaging in your application, building on top of this ecosystem. So now to the topic of today. So how can we now use Web3 technology to have a very good spam protection? Within this ecosystem, we have two ways to prevent spam or to block spam. So the first is server-based, which can act on this delivery service directly, so without any interaction with the user. And then we have client-based solutions, which need an interaction with the user. Yeah, let's look at this. That means spam protection is something which is in the protocol layer and something which is in the application layer. So first of all, we can have black and white lists. So we know it. There are lists, for instance, from the regulatory, so where they say, okay, these addresses are known spammers. You should not receive a message from them. We can use these blacklists, but as all of us know, blacklists in blockchain world is not a very efficient way. If I block or set an address on a blacklist, of course, people can generate a new address, and it's a game nobody can win. But for regulatory reasons, it might be very important to stop existing or well-known spammers to send messages. On the other side, we can also use whitelist if we have a closed ecosystem, but this makes it very complicated because to receive a message, the sender must be on the whitelist, which makes it very complicated to register. So for regulatory purposes, it's good. For spam protection, it's more a weak protection. It's not that good to use. So the next thing, we can prove the activity of the node. So the sender, the address of the sender can be checked if there is the nonce higher than 0. Now, if this is a new address, the nonce is 0, that means with this address, nothing has been done in the past. So, and if I want to prevent spammers from sending spam from newly generated addresses, I can say, okay, I only accept messages if the nonce is above a certain value, maybe 1, maybe 5 or 10. So which means only used addresses are able to send messages. That makes it very expensive for spammers. Now, if they want to generate a lot of new addresses, they have to do transactions with the addresses before they can use it for spam, which it's a good barrier. We call it medium protection. It helps to prevent spammers from easily generating new addresses. Then also we can check the ownership. If this address holds a token or an NFT, I accept the message. If not, I don't accept the message. So that makes it also very expensive for spammers, because if they want to use a new address, they have to transfer tokens or NFTs or coins to this address before they can use them. It's also for them very inefficient. For the user on the other side, it's in the most times not that complicated. So now with this, we can do some filtering on the server already, but then we can do much more in Web3. So what we provide is you can take your message and deposit tokens on this message with the promise that this message is not a spam. And what happens if this message is marked as spam by the receiver? These tokens are burned. So with this, it is very expensive for spammers, because if I say, okay, I only accept messages with tokens in the value of, let's say, 10 euro, then someone can send a message to me, and if I mark this message as spam, these tokens are burned. If I accept this message as a regular message, then they receive the tokens back. So they don't have any costs on both sides, but for spammers, it becomes really, really expensive, because if they send messages which are marked as spam, all this money is burned. And I can take it in the other way. I can also say, okay, let's accept messages, for instance, for ads, for advertisements, if they have a payment on it. So that the user can say, okay, I'm willing to accept advertisement messages if they are paying me, let's say, an amount of X. So and then I can send a message directly to the receivers with this amount locked to this message. And if they accept and read the message, then the payment goes directly to the receiver. So it's the same, maybe the same costs like I have if I'm using an advertisement on Google. But there I pay to Google that they send a link to my web page, and here I can send this the money directly to the receiver. So, and I don't need any intermediate in between. So with these protection mechanisms, that we can have these blacklists if we need it for regulatory purposes, that we can have a proof of activity, the nonce, we can have proof of ownership, that we can see if there are tokens or NFTs on this address, and this locking from tokens to a message, so that this will be burned if it is spam. We can build a very secure and very easy to use spam protection system. For the end user, it doesn't really see that the spam protection is in work. Now, we don't need a spam folder for this, where we filter out messages because of content. Here we say, okay, if these criteria are fulfilled, messages are accepted or not, and everything based on Web3 technology. Okay, let me give a summary of my talk today. So we talked about the challenges we have in Web 2 and Web 1 messaging today: encryption, privacy, self-reliant interoperability, and so on. And that with Web3 messaging solutions, we can solve these problems very well. But we have to keep in mind, and I repeat it once again, if we try to do it in Web3 separately like it is done in Web 2, we will not be successful. We need interoperability, we need the way that we connect our ecosystems together. And we can use these technologies very efficiently to have spam protection, so that we can use our messaging solutions with very efficient algorithms, so that messaging of the future can be done based on Web3 messaging. Thank you very much for your attention.
Thank you so much, Steffen. So the floor is open for questions.
Thanks, nice presentation. I have a question. Could the dark web be motivated to use this protocol?
You mean, so of course, yeah, you can use every protocol for good and for bad things. That's true. So we cannot prevent people from using a protocol. We cannot prevent them to use blockchain as well as we cannot prevent them to use PGP and a protocol. So yeah, that's the reality.
Question over here. Yeah.
So one of our clients, they want to do this direct advertisement with payments, but they want to also create profiles for the user so that there is more of a discoverability whom I want to send a target ad to. Would this be something that you would be interested in supporting? That this would be more of an integration to use your network as the payment layer, but then a discoverability of the people, so basically a profile of their data, and then on the other side, the advertisers would be able to access this. Would this be something interesting for you guys? Then we could have a follow-up.
So it's an interesting question. So if I understand it right, so there is someone who wants to send advertisements to users, and then yeah, they can use the DM3 protocol. So the user decides if they want to receive such message or not. So we don't have any personal data of the user at any time. Now, DM3 is fully self-sovereign, organized by the users. The only thing which is available is the address and the communication profile which is on the ENS name. So this information is available. But any other information, if I want to have some personal data, this depends on the user, if he is willing to send it.
Sure, this would then be the part where we would integrate your protocol, but the functionality seems like a perfect fit because this is exactly what should happen, this payment.
Yeah.
Okay, thanks.
I saw someone raise their hand on the other side of the room. Yeah, they were first. I'm coming back to you.
Thanks, great talk. So the biggest problem that I'm seeing is the nodes. How many nodes you have, how do you set them up, what are the incentives for the node operators? Can you talk a little bit more about that, just to understand how the relaying happens?
Yes, so these nodes, so we as DM3, we don't want to operate these nodes. So we are providing the protocol, and everyone can run such a node by himself. So I can run my own node at my home server, or I can take any provided service node which is provided maybe for a payment or whatever. So the good thing on DM3 is that these nodes are completely independent. Now, they are not connected, so that it scales very well because new nodes can be added to the network and increase the bandwidth of the network. So your question is, how many nodes are operated? So at the moment, we are operating some nodes from ourselves, and the protocol is in early stage. We now have published the specification, we have published the reference implementation for this, and we are in contact with a lot of ecosystems and tools that they start now to implement it. So,
But why would people run nodes? It's one of the biggest problems of any type of network. What's the incentive for someone to be like, oh yeah, I'm gonna...
So the question is, why should people run nodes? So first, for my communication, I should run my own node for this. So, or if someone else is providing the service, then there will be a payment for this, so that I take the service from this community and then have a payment for this.
So thank you so much. I'm sorry I told the people that I'm coming back, but we are out of time for this. So please find Steffen in the break if you have more questions. Thank you once more.
Yeah, thank you.